So, good morning, everyone. Last year at Tech Week on the quantum stage, we presented a new model of innovation to help supercharge the UK's science superpower potential. This year, in doing that, we looked across to examples from Japan, their Q-Star Alliance in Quantum, which brings together over 50 different companies onto a central campus to co-create solutions with leading tech companies like us. We're one of the 14 that lead it. We looked at the research on what it takes to enable innovation. We looked at some of the fundamental problems the UK faces in achieving the Prime Minister's agenda to make the UK a science superpower. We looked at how, according to the CBI in 2016, the UK was 27th of the EU 28 for the ability to commercialise technology, and how the Enterprise Research Council at that time had just published a report showing that since 2010, we'd gone consistently backwards on that measure. We talked about how to win in quantum and AI or large-scale compute, all of those things that would be symbiotic and one would need to power the other. And we talked about how throughout history there had been three major revolutions in how humans use tools. The first, physical; the second, informational, allowing us to move information around over distance and time; and now today, cognitive, allowing us to generate new insights. And we talked about how the combination of quantum, AI and large-scale compute would bring a revolution, and how Fujitsu saw the future as a cognitive technologies company, not just an information technologies company. We provided specific, actionable recommendations for what we thought was needed across the UK system to enable that science superpower vision to flourish. Yesterday, you've heard Vivek Mahajan give a bit more detail, our global CTO, give a bit more detail, building on the announcements by Lord Grimstone in the Office for Investment, Kwasi Kwarteng, and a number of others yesterday, talking about our Centre for Cognitive and Advanced Technologies, a £22 million investment in the UK economy, and a big bet on the kind of cognitive technologies I talked about last year. This is us moving from talking the talk to walking the walk. What I want to talk about today is a bit more about that Centre for Cognitive and Advanced Technologies, or the CCAT, in the wider context, to give you an idea of what we're doing and how we might go about it. Ultimately, what we're trying to be is an exemplar of how you commercialise innovation within our company, to catalyse that rapid commercialisation of research, both for Fujitsu, but also that being that new model of innovation that I talked about last year. Jack Welch, CEO of General Electric, once said that when the rate of change inside an institution becomes slower than the rate of change outside, the end is in sight. The only question is when. Now, Jack Welch in his work with General Electric got many things wrong, but I think he got this right. And Fujitsu, throughout its history, has changed. We started as an electrical motors and generators company. Then we became a telecommunications and radio communications company. Then in the 50s, we started to take bets on the emerging technology of computers. And in the 60s, we took a really bold bet that computing would be the future, founded a new company that eventually replaced the old one. And that's the business that you know today, that's gone through many iterations as a network and services integrator and a number of others. Constant business model innovation. But starting with why do we need the CCAT? Well, it's because, as Jack Welch said, that rate of change inside has to keep up with the rate of change outside. And as we'll see on the next couple of slides, the rate of technological progress has increased exponentially. You can no longer wait a decade, as we did in the 1950s, to see an emerging technology, to track it, and then take that big bet. By the time you react with these kind of technologies, you're behind. You have to predict, and you have to get after it. Winston Churchill once said that the further back we can see, the further forward we can look. And I thought I'd start today by using the breakthroughs in AI as an exemplar of the speed of technological change. If we place ourselves in 2010, advocates for AI were laughed at. Nobody thought artificial intelligence was going to go anywhere. There was really no AI anywhere, or machine learning at least, outside of the lab. If you were talking about quantum, you were probably nostalgically referring to a kind of 1980s TV show, rather than something that might be here tomorrow that businesses could seize and take advantage of. In 2010, DeepMind had 4 employees and no products. Self-driving cars were thought to be something from science fiction and the future, and likewise flying taxis. Today in China, you can get in a robo-taxi and it will take you to your destination, and they're looking to scale those rapidly. Coventry and Rome are currently competing to be the first for vertical lift and urban mobility, in other words, flying taxis. These things are no longer science fiction. Thinking back to 2010 again, where were we? If you were to log on to Google and do a search, there was no AI curating your feed, no machine learning that sat behind it. If you were looking at Twitter or Facebook, your feed was chronological. It wasn't personally tailored to your personality, your likes, and your dislikes. Only 2 of the world's largest technology companies were technology companies. Today, 7 of the top 10 are tech companies. If we think a little bit beyond that, some of the more laughable things is people thought it would be a decade before we had machines that could accurately recognize cats in images. Today, we have remarkable breakthroughs in image processing that go well beyond that. I think if you were talking about cloud, you were thinking about an object that was in the sky. If you were talking about data, you were probably thinking about a mobile add-on plan, not a national security priority. Nobody had heard of Baidu, Alibaba, or Tencent. TSMC and companies of the like were not thought relevant for national security. The point, again, is that by the time you react, you're behind many of the things in your commercial organizations and your companies and in government that you think are fundamental barriers to progress tomorrow will not be. Let me take one thing that I think really drives this home from a human perspective. In 2010, most psychologists, neuroscientists, and computer scientists thought it would be 20 years before a machine could pass the Turing test, where in a dialogue behind a wall you were able to recognize whether the computer was a computer or whether it was a human that was talking to you from the other side of the wall. Since 2020, the Turing test has been passed on a daily basis. Psychology experiments have shown that humans can't tell now whether it's a human that they're speaking to or not. When there was a psychology experiment run where there were no computers involved, you were the other side of the wall, and you had to figure out whether you were talking to man or machine. 42% of the time, people thought it was a computer they were talking to. In California, we've had a guy using GPT-3 to resurrect his dead girlfriend by feeding text messages into GPT-3 that then can have a dialogue with him. Over the weekend, we had an admittedly slightly odd Google engineer looking at their latest Lambda language model, claiming that it was sentient and having really quite in-depth conversations with it. Now we can scoff at those breakthroughs. The point is, in 2010, we thought the Turing test would never be passed. Now we have a man falling in love with a language model and another guy getting fired for thinking the computer he's talking to is sentient. So I think, again, if you're in a commercial organization or government, you have to think, what are the things that I think are impossible now that in a decade won't be? It's often said that we overestimate technological progress in the short term, the 1 to 2 year time frame, but in the 5 to 10 year time frame, we consistently underestimate it, and I think that points it out. And there's no way I can go through these unless I talk to you for about 3 hours, and I have tried in rehearsals. So I'm just going to touch on some of the things that we've seen in the last 12 months to give you an idea of that exponential increase in progress. 1950s, if we look back to that, we had a decade to the 1960s as Fujitsu to take a big, bold, and early bet on computers. In 2010, you had about 3 years to make that big bet on AI, or you were behind everybody else. In the last 12 months, we've seen DeepMind go from being criticized for never solving a real-world problem to being able to identify 3D proteins using AlphaFold that will lead to breakthroughs in medical science that we thought we'd never reach. We've seen nowcasting, highly accurate weather forecasting, again from DeepMind. Remember, a decade ago, it had 4 employees. The Pascal and Q&Co merger is just one example from the quantum world of the increasing mergers between different companies, where we're seeing companies now predict that they will have a practical quantum computer, in Pascal and Q&Co's case, within 3 years. The merger between PsiQuantum and Global Foundries, or rather the collaboration between PsiQuantum and Global Foundries, has suddenly given credibility to claim that they'll have a practical quantum computer in 5 years. Now, some of you might scoff, but remember, you'd have scoffed at me in 2010 if I was talking about the kind of breakthroughs I've just described. As I said, I won't attempt to go through anything like these, but I will pick out a couple. The Google breakthrough in Socratic models with AI is remarkable. That is AI or machine learning models that, multiple different machine learning models, each trained to do one thing extremely well, and then to communicate with each other to work out answers to problems in the way that one specialist human might speak to another specialist human in a kind of Socratic dialogue to work out the answer to a question. It's truly, truly remarkable. And AI is now literally an arms race. There are autonomous weapons deployed or semi-autonomous and autonomous weapons, AI everywhere on the battlefield now in Ukraine, AI feeding the intelligence that supports that. It's a national security priority, and it's a business essential. So we believe that those breakthroughs in AI machine learning will be symbiotic with breakthroughs in quantum, exponential increases in computing power, and that in turn will be in part dependent on large-scale compute and supercomputing, which is why Vivek was talking yesterday about the advantages that our world-leading quantum simulators can bring for allowing us to understand and develop applications for quantum computing before true quantum is here. We think at its heart, what these technologies offer is a cognitive revolution, the ability to deliver unprecedented insight and foresight into the future. Now, psychologists like Baumeister and others, they published a book a few years ago called Homo Prospectus, which claims that the fundamental thing that defines what it is to be human is the ability to anticipate, imagine, and predict the future. And what we're seeing now is the technologies that can do that at least as well as we can. That is a profound opportunity, again, for everybody, whatever organization or business you might be in. And we want to harness that cognitive revolution. We want to revolutionize how individuals and organizations make decisions. But we also see the profound downside risks that come with that kind of opportunity. We see the risk to human agency when those behind technology can know us better than we know ourselves, anticipate our actions, and predict the future perhaps better than we can. We worry about what that means for when autocracies use that to control people, and we worry what that means when commercial organizations use it to exploit people in radical new ways that are beyond our understanding. We worry about what it means for social cohesion. We worry about what it means when the lines between the virtual and physical, between man and machine, begin to blur. And consequently, what we're doing at Fujitsu with a lot of our big early bets in AI and machine learning is start to think, well, how do we build the seatbelt before we build the car? What we're doing in practice is we're investing really heavily in explainable AI, both in Japan and with the University of Manchester here in the UK. We're investing in adversarial AI so that our models decline gracefully and that we understand when they might be being attacked. We're investing heavily in data and AI ethics to recognize whether data is biased before we feed it to train the models and to track the models in practice. We are trying to be as human-centric as possible, worrying about what this means for humans as much as, and the downside risks as much as the opportunities. So the CCAT will be focused on revolutionizing decision-making for individuals and organizations, but starting with how do we protect them from the implications of our understanding of what these technologies promise. We also believe that innovation happens at the intersection, and by that I mean at the intersection of different academic disciplines, at the intersection of different business sectors, at the intersection with government departments and academia, and between different minds and working collaboratively with machines. Innovation ultimately is not about technology silos. And one of the reasons that what we've announced is a Centre for Cognitive and Advanced Technologies, and not a quantum centre of excellence or an AI quantum of excellence or so forth, is that we think those technology silos are fundamentally limiting. When Vannevar Bush first built the differential analyzer, which originally was an analog computer designed to go well beyond human performance in mathematics that he built at MIT, I should say for the eagle-eyed, this one is at Cambridge Uni rather than the original one. We couldn't get a licensable image for the US one. But the differential analyzer brought together multiple different technologies. Those that were building it were from disciplines like most of the early AI/ML pioneers. They were from psychology, neuroscience, mathematics, physics. They weren't just one discipline. And they were thinking about, well, what does it mean when we have superhuman performance enabled by the kind of technologies that we take for granted today? They were inventing the field of cybernetics. And that's what we're trying to do, bring different academic disciplines together. If you're revolutionizing decision-making, it makes no sense to develop these kind of technologies in sectoral silos. Something that revolutionizes decision-making for a bank is every bit as relevant for a national security professional or for a scientist. And so we're trying to think about how we bring all of those things together to rapidly accelerate our own innovation. So it's innovation at the intersection of multiple different areas. You'll have seen this slide last year, and I won't linger on it, but the point I wanted to make was the kind of callback to what we talked about last year. Every major breakthrough in artificial intelligence has come about through increases in the availability of large-scale compute, and that's what the graph shows, so many of those headline things. CSET last year published a paper that described how the next wave of breakthroughs in AI will be dependent on three things: algorithms, data, and compute. And that's why, at the time, Fujitsu's Fugaku was the world's fastest supercomputer in all of the major rankings. And I bragged on stage about how this chart showed just how effective it was, with all of those last four being Fugaku. Well, we still have the second fastest supercomputer in the world, but as of a week ago, the fastest is Frontier in the US, and if I was to try and chart it on there, it's twice the speed of Fugaku. The point, again, is that speed of change we need to keep up, as do the rest of the world, and the point is the symbiotic relationship between breakthroughs in quantum and breakthroughs in AI and machine learning. That cognitive revolution, again, is happening at the intersection, and so high-performance compute, AI and quantum will be technologies we bring together to pursue that revolution. Vivek yesterday talked about the CCAT being an innovation bridge between the UK and Japan. And you might be wondering what that means in practice, so I thought I'd break it out briefly today. You can see the government's ambitions stated there in the PM's ambitions to build a general-purpose quantum computer, and the UK's large-scale compute report, sponsored by the Chief Scientific Advisor, Patrick Vallance, to improve our performance in large-scale compute. Where I think the UK's fastest supercomputer is the Met Office's, it's 38th. If we want to be a science superpower, that has to change for all the reasons that we've just described. And we hope that we can align the UK's ambitions in that area with those of Japan and act as an innovation bridge to build practical projects, Anglo-Japanese projects, to allow our two countries to succeed in these fundamental technologies that are crucial if we are going to keep up with the autocracies that we worry about developing the kind of power that comes from having these technologies before we do. We also see opportunities to solve some of the mission-driven or moonshot innovations that many countries are talking about. Those things the market struggles to address, but we think, but governments can. So if you look at BEIS's innovation strategy, it names a number of missions. If you look at Japan's 6th Basic Plan for Science, Tech and Innovation, it names a whole series. Many of those look very similar. And one of the things we'll be talking to the Japanese government and our colleagues in the UK government about is, well, which of those might we align and work on together to accelerate the progress at the intersection between our two nations? So that begins to give you an idea. Some other practical things we want to do with the CCAT. One is the UK's trade treaty with Japan opens up possibilities for UK small and medium enterprises to access the Japanese market, and for Japanese small and medium enterprises in tech to access the UK market. And we aim to be the innovation bridge that helps make that happen through a combination of corporate venture capitalism and facilitating access and collaboration agreements. The trade treaty also talks about the UK and Japan sharing national strategic data, and we're going to need somebody to be a data steward to make that happen, and we're interested in taking forward the dialogue on how Fujitsu might be a part of that. We also talked last year about this technology innovation that we're talking about is all well and good, but the organisations that win in the 21st century won't be those that arrive at the start line with the best technology and the best research, but rather those with the most agile bureaucracies, the most adaptive way to overcome the obstacles that you'll face as the race gets underway. And what that means is that we need business model and process innovation in order to have the kind of technological innovation that we're seeking. So very briefly, I'll touch on how we're going to try and do some of that through the CCAT. The aim here is that the CCAT becomes that catalyst for wider innovation within the UK business and perhaps the wider Fujitsu, and an exemplar for the country in how you commercialise technology faster. And the reason for that is we don't want to be a walled-off, a kind of walled-off skunk works from the rest of the business. We want to try out new things that might facilitate wider success. And so that means having a clear planned strategy, which is kind of out of fashion at the moment, but without a planned strategy, it's like playing chess without first deciding your strategy to beat your opponent. We'll have an adaptive strategy which understands that plans are nothing, but planning is everything. So you have to have a plan, but then you have to watch to see what your opponent and others in the environment throws up and adapt to it. So designing the system to sense, adapt, and respond to changes in the environment so that your plan is constantly adapted. And an emergent strategy that understands that strategy doesn't take place in some sort of abstract vacuum. It takes place in the reality of people, personalities, and processes, and has to be adapted to succeed. We're going to make a much greater reliance on the explicit over the tacit. So most organisations today, despite the availability of data, still rely on heuristics to make most of their decisions. We will be much more explicit in delineating the principles on which we're going to make our decisions and making all of our decisions deeply data-centric. We will manage time much more effectively than many organisations do, understanding that urgency bias can mean you rush to the wrong solution or set off in the wrong direction. So overcoming urgency bias, but also seeking to fail fast. So once we've decided the direction we're going in, we want to fail fast to learn and then continuously adapt. So two kind of paradoxes of strategy making, but understanding them and trying to harness them. And then lastly, focusing on the who and the how before the what and the when. So Netflix talks about a strategy of talent density, getting great people together to tell you which way to go. Steve Jobs used to talk about how he hires great people to tell him what to do, not so he can tell them what to do. And so the first is focusing much more on the who and the how before you rush to decide what you're going to do and when, which is why we'll have a further announcement towards the end of the year that describes the CCAT in much more detail. The problem with putting the what and the when first is people become personally invested in the things that they're putting forward and defend positions rather than try and work out the principles on which the decision should be based. So we think those are some of the ingredients that will be needed to turn us around on that constantly declining chart in the UK, where we've gone backwards on the ability to commercialise new technologies. And we'll work to a single KPI, the number of new-to-market and new-to-firm inventions as a percentage of turnover, seeking to catalyse and facilitate the success of the wider business. Now, I'm only going to tease you here with some of the things we're already doing, because I said we'll have another announcement towards the end of the year that gets into more detail. But we haven't waited for the announcement of the CCAT to start on some of these ambitious projects that we're talking about. We have a number of vanguard innovations that are already underway, that already match our ambition with action. And in the autumn, autumn pre-Christmas, I hope to have a much deeper announcement on what we're doing. The first is working with the Department of Business, Energy and Industrial Strategy on their cyber-physical infrastructure or connected digital twins program. Also working with Japanese colleagues on their Society 5.0, which talks about the digital transformation of society, the fusion of the virtual and the physical, integrating all technologies from quantum annealing and quantum-inspired annealing, to AI, to machine learning, and many other technologies to blur the boundaries between the virtual and physical, bringing augmented reality and virtual reality, answering what-if questions using synthetics and simulation. And that's all part of our key focus area within Fujitsu of trusted society, and I'll give you a lot more detail in the next major announcement for the CCAT. We're also looking at collective intelligence solutions. So HiveMind is a program that we run with MIT in the US and a small UK-based consultancy, Aleph Insights, that aims to bring collective intelligence to decision-making, by which we mean when man and machines operate intelligently together. So where you take the science of high-performance teams that says, how do we get a human team to perform to its maximum, the psychology of that, and then what we say is, what happens when that interaction is mediated via technology, and what happens when some of those intelligent agents are machines themselves? How do we get the best out of people then? So again, thinking about how we get the best out of everyone through man and machine. And the last that I wanted to very briefly touch on is explainable AI, where we're investing in an explainable AI knowledge base that automatically connects objects, entities, and events in much the way that you might think of an investigations or murder board was in a police drama, does it on a time-based, event-driven architecture, and helps to drive fundamental insights from data much faster and in a much more explainable way than anybody currently can, building the seatbelt before the car, making it explainable. So the aim here is that we are a catalyst for wider innovation in the UK economy, an exemplar, and a catalyst for innovation within the company and globally. Thanks very much for listening, and if we've got time, I'll take any questions.
Have we got any questions from the audience? Understand.
Thank you. My name is Dimitri French. I work for Amazon Web Services. Sure, with no huge surprise, I'm wearing this T-shirt. My question is about those innovations that come across as impossible today, but may not be in the next few years. And thank you very much for a very inspirational talk. Now, if you had to choose one technology or one innovation, which is maybe, almost in the science fiction domain today, but may not be in the next few years, what would it be?
I think on the quantum stage, you have to say quantum computing, don't you? But I think genuinely that will be so revolutionary. It will blow apart the chart that I showed on computational power. It'll enable fundamental breakthroughs in science. I think a bit like when the internet was introduced, we don't know yet just how profound the implications of a true, stable, practical quantum computer would be. So I think at the moment there are many who rightly would point out all the barriers to progress and the reasons we might not get there, but I think that would enable the kind of science fiction breakthroughs that we've seen in the last decade, but now treat as if they were normal and always anticipated.
Thank you.
Have we got any other questions from the audience at all? Okay. I think we are just at about time, so if you'll all please join me in thanking Keith and thanking him for the stage.